All right, so this station is over two different stations basically. First, we're going to talk about elements, compounds, and molecules. So you'll need to take up all of page 23 for elements, compounds, and molecules. You're going to write out the element names and the definitions of them. And I'll go over the definitions. An element is the simplest form of matter. These are listed on the periodic table. What that means is sometimes you may have a question that asks you, is an oil an element? Is water an element? Is steel an element? Different things like that. If you cannot find it on the periodic table, that means it is not an element. All elements are listed on the periodic table. Hydrogen, sodium, helium, all listed on the periodic table. A compound is two or more different chemical bonded elements. You would not see them on the periodic table. The most important thing that you need to take from that is that word different. If I were you on my paper, I would circle the word different. Two or more different chemically bonded elements. You will not see them on the periodic table. For instance, one is H2O, which is water. That has one element, which is hydrogen, and another one, which is oxygen. They're bonded together to make water. All right, you won't find water on the periodic table, but two different elements chemically bonded together is a compound. Another example of a compound is CO2. You have carbon and you have two oxygen atoms that are bonded together. So CO2 is another compound. Now here's where people get compounds mixed up with molecules. A molecule is two or more of the same or different atoms chemically bonded together. So two things there. They can be different, like compounds, but they also can be the same bonded together, like H2 or O4 or N3. All right, if they are the same bonded together, then that is a molecule. If H2O, remember I said they can also be different. So H2O would also fit the mold of a molecule. So listen to this part very, very carefully. All compounds are molecules, but not all molecules are compounds, because compounds only deals with two different elements, while your molecules can deal with two different elements, which would make it a compound, or they can deal with two of the same element, two or more of the same element. So that is your elements, your compounds, and your molecules. On page 30 of your book, you're going to take your sheet that says photosynthesis. You're going to take that sheet, and I want you to cut out that rectangle. That way we don't have to write this formula over again. That formula for photosynthesis, you're going to take that and cut it out. I'll do that as I go. Just a second. Alright, so I'm cutting it out. Alright, so I've cut that out and I glued it in. So I have this formula here is what you just glued in. This is the formula for photosynthesis. Before we start dealing with that formula, I'm going to talk you through a couple of things. We need these primary definitions. I want you to write these definitions. Take the lower half of your page, and you're going to write out what a reactant is, what a product is, what a subscript is, and what a coefficient is. Now, this will also help you for one of your stations in the back that you have to look up that information. A reactant is elements, compounds, and molecules on the left side of the arrow before a chemical reaction has taken place. So if you look at your photosynthesis sheet here, this part here, this 6 CO2 plus 6 H2O, this whole section here would be considered your reactant. If you notice in your reactants, you have carbon dioxide and you have water. These are your reactants. They come before any type of chemical reaction. This arrow means yields. That's telling you that a chemical reaction is taking place. This part back here, C6H12O6 plus CO2, which is sugar and oxygen, is what we call our product. Compounds and molecules to the right of the arrow. This is the result of a chemical reaction. This happens after the chemical reaction takes place. So you have your reactants that produce your products. Your reactants produce your products. We have a chemical reaction that is taking place. Remember, in a chemical reaction, a new substance is formed. A new substance is always formed in a chemical reaction when a chemical reaction occurs. So the law of conservation of mass states that matter can neither be created or destroyed. It can only be rearranged to form a new substance. Look at here. We had carbon dioxide. We had water. We rearranged what we had up top. And in the end, we got sugar and we got oxygen. All right, so doesn't that make sense? Matter can't be created or destroyed. We didn't create anything new from over here on this side. All we did was changed up. We still have the same number of elements. The exact same elements. We have carbon, oxygen, and hydrogen. Over here we have carbon, hydrogen, and oxygen. So we still have the same elements. We still have the same number of those elements, which I'll show you in a few minutes on either side. All we did was change them up, rearrange them a little bit, and formed a new substance, sugar and oxygen.